All right, so get this. Have you ever actually tried explaining like a pun to a computer?
Or sarcasm.
Yeah, or sarcasm, exactly.
It's impossible.
It's really hard.
Yeah.
Turns out teaching a machine to understand language, something we humans do without even thinking,
Right.
is a really monumental task.
It really is. It's kind of like, what's that saying? Like trying to teach a fish to climb a tree.
Yeah.
The tools we were using, they just weren't designed for the job.
Yeah, they were totally the wrong tools for the job. Okay, so let's unpack that. Our deep dive today is into the world of machine learning, and a paper with a title that's both bold and surprisingly accurate. Attention is all you need. We're going to break down how this idea of attention kind of revolutionized the way machines process language.
And beyond, actually. But
Oh, really?
yeah, we'll get to that.
Okay, spoilers.
A little bit, yeah.
All right. So before attention, we have these things called recurrent neural networks, RNNs for short.
Right.
Think of them as kind of like the workhorses of language processing for a long time.
Yeah, they were really the big deal for a while because they introduced this idea of memory, right, into the process.
Okay.
So imagine you're reading a sentence and you're trying to remember the previous words to understand the context.
Right.
That's what RNNs were trying to do. They were trying to replicate that.
And some, like LSTMs and GRUs, got really good at it.
They really did. LSTMs and GRUs, these were like the superstars of the RNN world. But
there was a catch.
yeah, there was always a catch. And the catch was RNNs process information sequentially, one word at a time.
Okay.
It's a bit like, watching a movie one frame at a time.
Okay.
You might eventually get the whole picture, but it's going to take a while.
Yeah, especially if you're trying to get through, like, War and Peace or something, like one frame at a time.
Yeah, good luck with that.
So speed was an issue, obviously.
Indeed was a huge issue. And you see the sequential nature. It's like it's built into the very foundation of how RNNs work. It's like,
It's inherent to the...
It's inherent, yeah. It's like trying to make a snail go faster. You can encourage it, but it's still a snail.
So researchers were basically stuck trying to make these inherently slow models work faster.
Yeah, pretty much. I mean, they came up with, some clever workarounds like factorization tricks or conditional computation. Think of them as kind of like
like shortcuts.
shortcuts, yeah, to speed up the process.
But those were just Band-Aids on the problem, right?
Exactly. The core issue remained. RNNs were fundamentally limited by their need to process language sequentially. It was like, I don't know, a one-lane highway trying to handle rush hour traffic.
Yeah.
Always going to be a bottleneck.
It's like they took that one-lane highway and said, forget this, let's build a superhighway,
Yeah, totally. It was a really bold move. They stopped trying to make RNNs faster.
Right.
And just ditched them entirely.
Wow.
Yeah, the authors of this paper, they introduced this totally new architecture. They called it the transformer.
The transformer,
Yeah.
okay. So
Yeah.
pretty epic.
Yeah, it really does, and it kind of lives up to the name. The key innovation here is the transformer gets rid of recurrence altogether.
Okay.
And it relies entirely on these attention mechanisms that we've been talking about.
Okay, so this is it. This is the heart of it all.
Yeah.
Can we dive into what attention actually means in this context?
Sure.
Because I get how it applies to humans, but how does a machine learning model pay attention?
That's a great question. It gets at the core of how these models understand relationships. So imagine you're reading a sentence. You're not focusing on every single word equally.
Yeah, totally.
Yeah.
Some words just kind of jump out at you as more important.
Exactly. Your brain is kind of like automatically figuring out which words are crucial, which ones are really important to understanding the meaning and attention mechanisms in AI. That's what they're trying to do. That's what they're trying to replicate.
So how do they actually do that? How do you teach a machine to prioritize certain words over others?
Okay, so imagine you're trying to find a specific recipe in a cookbook.
Right.
That's your query. Okay. Each recipe has a title, that's like the key, and then there's the actual recipe itself, that's the value.
Right.
Attention in AI is like having this magical index that instantly tells you which recipe titles actually match your query.
Oh.
So you don't have to waste time like flipping through every single page.
So instead of reading the whole cookbook cover to cover,
Yeah.
it's like I can just jump right to the good stuff.
Exactly. It figures out the most relevant parts of the input and just focuses on those.
Oh, that's really cool. I like that.
Right.
Yeah.
So the paper, it introduces a very specific type of attention. They call it scaled dot product attention.
Which sounds very complicated.
It sounds very complicated.
Yeah.
But it's really elegant, and it's actually, at its heart, pretty simple.
Okay, break it down for me.
Okay. So think of it this way. Imagine each word in a sentence is like a point on a map.
Okay.
Okay.
I visualize that, yeah.
Scaled dot product attention basically calculates the distance between your query word and every other word.
Right. And the closer those words are on this map, the more related they are.
So it's like those "you are here" maps, but for words.
Exactly. And the really cool thing is this can be done so efficiently on a computer using matrix multiplications.
Oh, okay.
It's like having this super fast calculator that can just process all these relationships like instantly.
So faster, more efficient, and it makes more intuitive sense.
Yeah.
But they didn't stop there, did they? There was something about multi-head attention.
Multi-head attention, that's right.
Is that as wild as it sounds?
You're catching on. You're absolutely right. So remember how we talked about different types of relationships between words?
Yes.
Multi-head attention